Well, good morning, ladies and gentlemen. I think we'll get this started. Welcome along to the third annual meeting of the East Midlands STEM Partnership. We're delighted to see so many people here today. I think it's a real credit to your commitment to this cause that so many of you have turned up. I'm now going to introduce the first speaker, who's Michael Carr. He's the Director of Business Services at the East Midlands Development Agency. Michael sits on many various industry bodies. He deals directly with the Department for Enterprise and Business, and more importantly for today's purposes, he tells me, a STEM graduate, and he's also worked at Rolls-Royce in the past. So, hand you over to Michael. Thank you.
Well, good morning to you and welcome to all. I mean, you'll be aware that historically the UK has an economic edge in the creation of new technology and ideas forged from the Industrial Revolution. What's more, the East Midlands has led the world in technologies such as MRI scanning, genetic fingerprinting, space research, and I couldn't not mention being here the development of the jet engine. EMDA itself has recognised this and has chosen to invest some £6 million in a programme of science, technology, engineering and maths related subjects to inspire and hopefully engage young people in presenting science in a more creative way, making it more exciting and more relevant to young people, and thus creating the scientists even and engineers of the future. We are looking to the next generation, our children, and possibly in the future, for me anyhow, our grandchildren, to be the scientists and engineers of the future, to ensure that the East Midlands continues to prosper and flourish as a competitive global economy. Thank you very much.
Well, morning, ladies and gentlemen. Great pleasure to be here. I'd like to congratulate EMDA on the vision of creating this partnership and bringing together this group here, because one of the things I will be saying is that we've got an extraordinary range of partners all wanting to do the same thing, which is, broadly speaking, to do what Michael has been urging us, get more young people involved in STEM. But I'd like to set out a few thoughts about the national framework and maybe try and show why the way that we're doing things and the way you're doing things here today is actually part of a strategy. Although it does look as if there are a lot of random initiatives going on, it is becoming increasingly strategic. As I've said, there are many supporters for STEM teaching, and they range across the government, across foundations like the Wellcome Foundation, across academia, the Royal Society of Chemistry, the Institute of Physics, the universities, and of course industry too. So we've got all of these partners, and they're coming from rather different areas of the world, and one of the challenges is to get a framework that works for all of those partners. Because they are a diverse group of partners, it's important to focus on what we agree on that we want out of the education system. And quite simply, there are two things that are important to those partners. And one is, of course, good attainment. We need people achieving good standards in science and mathematics, particularly coming out of our schools. And if you like, for the government, that perhaps, until very recently, has been the most important thing. How many grade A's and A stars can we get at GCSE? How many level 6s at Key Stage 3? I think there's an increasing realization that simply getting people attaining well isn't in itself enough. It's the numbers who are engaged and wanting to go on studying STEM subjects further that matters at least as much. And when I go to talk to people in business, they don't say to me, there aren't enough people getting A's at A-level. They say, there aren't enough people doing A-level physics and mathematics.
Good morning, ladies and gentlemen. Yes, I work for Rolls-Royce. But actually, what I want to do this morning is talk about the aerospace sector generally, from a wider perspective at the outset. Sandy Leach's review and report in 2006 on skills in the UK was certainly a clarion call. It emphasised that compared to the 19th century, when we had the natural resources, the labour force and the inspiration to lead the world into the Industrial Revolution, today we are witnessing a very different type of revolution, one where success for developed countries who cannot compete on natural resources and low labour costs will be dependent on a more service-led economy and high value-added industry. Or to put it another way, more than ever before, our natural resource is our people, with skills being the key to unlock the untapped and vast potential. So, yes, more people are studying degrees, but are they studying in subjects that can be economically viable? Yes, there are many great examples of good best practice in the vocational training, but are we really making sufficient progress in the parity of esteem debate between the mainstream and vocational routes as originally envisaged by Tomlinson? Now, most of the focus has been on the scale of the challenge Leach set if the UK was to secure prosperity and fairness in the new global economy. However, just as important were the key principles he set out to underpin the delivery of these targets to meet the challenge. And I'd like to focus on two in particular. That there needed to be a focus on economically viable skills. The employment and skills system must provide real return for individuals, for employers, and for society at large. So where possible, skills should be portable to deliver mobility in the labour market for individuals and employers. And it must be demand-led. The employment skills system had to meet the needs of individuals and employers. Vocational skills must be demand-led rather than centrally planned. In other words, a fundamental recognition that the ambitions would not deliver economic benefit unless they were based on economically valuable skills that could be effectively used in the workplace.
In order to inspire teachers, we need to bring them out into industry, particularly those that have been out of industry for many years. And I know in the Science Learning Centre, I took a team of 44 teachers to CERN, physics teachers, and they came back inspired. What figures have you got about teachers coming from schools or colleges into industry and having a scholarship type of programme for them?
I can't give you any figures, I'm afraid, but I completely agree with the premise, which is that by putting teachers into industry settings, real-life work-related settings, they become engaged and enliven themselves. And anything that refreshes a teacher is a good thing to do, because enthusiasm is very infectious and is a major component of successful teaching. But also, of course, they've got the tools to show their classes what a wide range of occupations are available to them if they take STEM qualifications. And we heard a bit from Jed about the deficiencies in careers information in schools, and I think this is actually really quite a serious problem, and I don't think we'll ever address it through the formal school careers service, the careers advisory service within schools. How can the person responsible for careers in a school possibly be expert in the enormous range of careers available in STEM, let alone everything? But I think where we can make quite a lot of progress is by giving science and mathematics and D&T teachers a better understanding of the range of jobs that's available, so that through their lessons they can show the young people they teach what a wealth of careers there are available if they take STEM subjects.
Parents are a key influencer on career choice. We stood at careers fairs and had been bombarded by parents going, my kid's interested in science. What possible careers are there in science? And I think we've got an issue because careers materials tend to be focused perhaps at young people.
I couldn't agree more. I think the key is get them young, because the Royal Society did some interesting research which showed that out of 1,000 scientists and technologists they surveyed, 2/3 of them had made up their mind that they wanted to be a scientist before the age of 14.